So we worked on Katy, myself, Bruna, Matthew, and Robert, mentored by Woodron and Emilio. We worked on shape track segmentation. So the main idea was to be able to automatically segment GPS tracks based on sampling behavior patterns using geopandas and moving pandas. We initially wanted to pull out the distinct features that can most likely segment tracks and run some type of clustering to see if any particular subset of features would work well in separating the segments. We didn't go all the way to the clustering, but we'll only present what we've done so far. So this image here shows you an example, an overall shape track segmentation done in R, according to time of day, sunset, night, sunrise, and day. The survey was petal shaped, and it was, so also plotted on this map is two of Longhurst provinces, which we've seen yesterday, the EAFR and ISSG, which was plotted on along with a shape track, and the Longhurst provinces were plotted using a shapefile. So Katy will carry on now with the presentation with some segmentation done in Python.
Yeah, so our starting approach was to use a rule-based method to segment these trajectories. So we wanted to split up tracks whenever we saw a large change in an attribute. So for example, if the ship makes a sharp turn, or if you see a large change in speed. And so the implementation of this, Robert, if you want to scroll down to the functions. So the implementation was pretty straightforward. Essentially, the algorithm is iterating over these points in a trajectory. It's looking at a given variable that the user can input. And if it detects a change in points that's greater than some tolerance that the user can also input, then it'll generate a new trajectory. And so you can see with this function that it's keeping track of what trajectory ID each point should be assigned. And so a big goal that we had was to make this independent of the data set so that a user could use glider data sets or ship tracks or something else and not have to reinvent the wheel. And so here's sort of a test example just using glider data off the coast of Oregon. And so this is the tracks that our algorithm produced. So it's color coded by individual trajectories. And we're using a package called Moving Pandas that can actually take points and then generate or produce individual line or trajectory collections from there. And I think that's it for this notebook. So Robert, if you want to take over.
I wasn't sure. Matthew, do you want to talk about this example that using the LTER data?
Oh, I think that's more of, I think his example is in a different notebook. But yeah, this is an interesting example of just a trajectory that has a lot of north-south and then east-west components. And so it would be nice to be able to look at both the east-west and then the north-south trajectories separately.
Okay, well, I'm not sure. Matthew, are you going next? If you,
no, it's just another example of the same code, so you can go ahead onto your section.
Okay, well, very, very simple. Once we have a series of segments trying to figure out how to extract what was essentially the goal survey, the original survey, mixed with all of the additional noise of the ship transit. And so this is sort of a qualitative example done very simply, and and this is where we'll hopefully be moving forward. But using the same iterative segmentation that Katy just described to start by pulling in these data sets into moving pandas into a georeference data frame. And you can see these are sort of a large all over the place ship group. And you can imagine if you pulled from a database, you could have dozens or hundreds of ship tracks with lots of overlapping scenarios. And so you'd want to sort out based on, without having prior knowledge of what that survey intention was. And so the first thing to do is to sort of use the functions in moving pandas to get some of the properties of the track. And this was just very simple: length, heading, and speed, which are calculated for each trajectory after those trajectories are already sampled and assigned. And then I just did very basic, based on those three features, did some clustering using, again, heading, speed, and length to try to identify essentially the modes of the direction of the ship, to say this is more likely to be the primary survey, or primary components of the survey. And then again, using moving pandas to reassign these clustering assignments back to the original ship data set, which gives us these labeled ship segments that fall in line with what we expect of our east-west survey transects. And so the survey was actually mowing the lawn back and forth, but what this has done is broken up the survey by all of the station locations and removed all of the extra tidbits of transit and station, and instead left us with these labeled segments that are true station-to-station transects. That's all I had, Katie.
Yeah, I think as for next steps, I think we were talking about improving this clustering approach and trying to make this packageable so that scientists who don't necessarily want to get into the weeds could just add in a netCDF or a GeoJSON data set and then get out these nicely labeled trajectories.